Welcome in the next section. Now we will talk about the shared drive, the data folder. Before, we're creating two servers. Each server had independent data set on the app 1 and app 2. Now, load balancer was sending the request to app 1 and app 2, but each server provided the data which had locally. Now, we will creating the shared data folder which will be mounted on app 2 and app 1. Okay, that now, every time when load balancer requests any data set, any page from either app 1 or app 2, both servers will use the shared data storage to provide that file system. Okay. Advantage of this is that we have to maintain the data set only in one place. Once we update our website, the data files, the files, that file will be available immediately on the app 1 and app 2. In previous model, we have to update file on app 1 and then update file on app 2. More maintenance part. But then each server is fully independent. Okay, how we're gonna do this? Using our resources available in always free tier in Oracle Cloud. We have 200 gigabyte available data storage, the block storage. We used 50 gigs for app 1, 50 gigs for app 2, and then we can use another 50 gigs for block storage, which will be mounted on both servers. Okay, let's create the data storage. Now, to create the data storage, we log into the console. We're going to storage, block volume, and create block volume. Okay, I'm gonna call this block volume data in compartment demo, in the same compartment where the servers are. We're using the compartment demo. Okay, availability domain. The block storage, we have to specify to which availability domain, that all servers are in availability domain 1. Then we're gonna select domain 1. Default performance, that is size 50 gigs. Performance is balanced. The backup policy, you have option to select gold, silver, and bronze. Based on that policy, that block volume will be backup. Now you can have 1 month, 1 year, 1 month, or every day. Bronze, monthly incremental backup at midnight. Silver is weekly incremental backup, and gold is daily incremental backup, and retention 7 days. Cross-regional replication, I'm setting off. We don't using the multi-regions right now. You can use the key encryption which you manage or Oracle manage. Right now I'm leaving this to Oracle, and let's create block volume. Like you see here, the block volume is part of always free resources, the way how we create an amount which we use, because we're still using in the range of 200 gigs. Okay, that once our trial is over, these resources will still be there and we can still continue using those resources. Okay, what we have here. This is information about the performance, how much IOPS, how much throughput you have, and if you may have some bottleneck related to block volume performance, you may want to increase the size and I/O and performance functionality, that your block volume will have better performance to fit your required application. Okay, now once the block volume is created, now we can attach block volume to the server. Now let's go to each server instances. And we will attach that block volume. Click on app 1. And we have here link attach block volume. Attach block volume. And we're selecting device path. We're using the first. And we set this as read-write shareable. If we're gonna set this just read-write, it will be attached to this server. Read-write shareable allow us to attach this to multiple servers, and you have a third option, read-only shareable, where also is attached to multiple servers. After we attached, we have to make the configuration which allow the servers to use that block volume and write from multiple servers. Okay, the how to do the configuration is linked here. Okay, that I understand that data might become corrupted if the volume is used before cluster file system is installed and configured. That we have to create cluster file system. Okay, attached. Okay, close. Okay, now the volume is attached. Now let's go to the second server. Scrolling down to attach block volume. Attach block volume. Select the path using the same path. Read write, shareable, understand, and attached. Okay, here when you click on this link, you will see the commands which you have to execute. Now this is taking you to help page. Now the same commands which we need to execute, it will be listed here. Okay, once everything is attached. Okay, we have attached. Now we can see SCSI command and information. And to connect, we have to execute those three commands on running server, and to disconnect, there is another set. Okay, I copy this. Okay. Now we have the preparation done. Now let's log into our servers, app1 and app2, and let's see how this looks like. Okay, I'm logging to app1, open. And let's log into app2. Okay. Disk -L. We have to be root to perform this operation. Okay. Right now, before we executing the additional commands, we have only one drive, 50 gigs drive, which is mapped as root 35 gigs and OCI volume as a 10 gigs. Okay, we don't see yet the additional volume. And similar will be here on the second server. Okay, like you see, those servers configuration are the same. Now let's execute those three commands. And now we have a new drive, dev sdb, with 50 gigs space. And let's do the same on second server. And we have also here the same drive. Fantastic. Okay. Now let's go to some documentation. And we will follow the Oracle instruction how to set up the cluster file system. Okay. The first step is to open the TCP and UDP for 777 for this subnet. We're going to our subnet. Our public subnet. Okay, and we're adding the 10.10.1.0/24 and port 77. Oracle Cloud File System 2. TCP and now UDP. And let's see. We need to add ingress rules allowing the instance access through TCP and UDP. Now you have ingress rules, but also we should add egress rules. Now in our case we may not need to add egress rules because we allow all the protocols as egress, means outgoing protocols, but in case we remove this and we want to be very specific, then we may need to add egress for 777. Okay, that you have an ingress to incoming, but it is initialized by second server, right? That second server have to have egress rule available. Okay, we done this. Now next. Okay, here is the instruction how to do. Now, like you see, they're using the network 10.0.0.0/16. They're just passing this to complete network. I specify only my public network where this I want to apply. Okay, now create the block volume, which we already did. And now we installing Oracle Cloud File System tools on the cluster servers. Okay, that first we installing the OCFS tool. I'm gonna do this on both servers. Okay, one server is completed. And second server is completed. Okay. Now configure the firewall rules. I disabling right now the firewall on both servers. Okay, that we're not configuring the firewall rules. And they're asking to disabling the C Linux. Okay, good. And force, we already have permissive. Good, and force is permissive. We said this before also to permissive. Now, what's the difference between permissive and disabling? Disabled is completely disabled. There is no trace, no running check, nothing. Now, permissive, the C Linux is still monitoring your system, but it will not block the running application, but it will just record the exceptions, and you can review, you can see, you can validate if this what is running is good for you or you have some additional problems. Now, we're going to configure the cluster layout once we install. Our add cluster will call this data. Let's call this as a cl.data. And we're adding two nodes to this cluster. Okay, that we're running this on server 1 and server 2. And now we're adding the cluster nodes. Now, in cluster node command, you have add node to cluster data demo app1. Okay, I'm gonna call this app1 right now, and IP address of that server. And the same we're doing with second server, and we're putting IP address. Okay, now we have this done. Okay, and the same two commands we will executing on second server 1, and we adding the 2. Okay, now we can see our configuration. Okay, list cluster CL data. Okay, and we see that we have a node number 0 app1 IP address, the port 777, and cluster name is CL data. And we have second node, which is app2 IP 1.12 777 CL data. Okay, is our IP correct? Okay, 10.10.1.12 is correct. And let's see here, app2cb list cluster CL data. The configuration looks correct, and our IP is also correct, 10.10.1.11. Okay. Okay, that configuration is stored in config file etc ocfc2 cluster conf. Okay, that's the same what we saw through the command. We see that the same information are stored in that specific file. And that during the configuration, you can execute those commands on both servers as we did, or configuring one server and then take that config file and copy to second server to make sure both servers have the same configuration. Okay. Now, as we prepare the configuration, we need to initialize the config that the cluster can start. The O2CB init, when you're executing without the parameters, it will give you the potential options which you can use. As a first, for configuration, we'll go use the configure. Okay, on boot, yes. Cluster backing CBEC cluster data. We're writing our cluster name. No, sorry. Let's stop this. We want this at the boot. stack backing O2CB we're leaving as is. Then cluster to start CL data. Here we're writing our cluster name, and those remaining we leave as default, and we have all OKs. I'm gonna save this. Okay. Now we can see our status. We have information about the drivers file system, loaded file system mount, check OCB heartbeat not active. That CL data is online right now, that we have configured one server. Now let's do the same configuration on second server. Status. Okay, we have a checking heartbeat not active, not active. Okay. Now next we need enabling the command on, enabling the service using the system control command on the cluster members. Okay, this will configure the startup. And next we need to upgrade our system control config file on both cluster members to add this option. Okay, I like to always add the last line to ensure I don't have any potential Okay, we add this. We are implementing the changes to the syscontrol. Syscontrol P. Oh, okay, I make the mistake. I didn't make the commands. Command line. Okay, it's good. Okay, now once we complete this step, okay, where that is notes. Okay, this is this, and now we can creating the volume. Our file system is dev sdb. We can see this using the fdisk command. Okay, this is this drive, dev sdb. Okay, and let's run the same on second server. Okay, because this is the same shared drive and the file system is the same, that once we executing this on one server, that's actually, you should not do this on second server. Okay, and okay, that here is broken. Here is formatting journals. Use mkocfs2 command to create file system. Okay, I interrupt this. Use mk command to create the file system with the label and dev1. Okay, let's see. Couldn't open device, no such file director. Okay. Now disk -L. Okay, here we have just this device. We don't have a partition 1, 2, or 3. That we're going to use fdisk to create the partition 83 as a Linux partition. Okay, on the list of the available partitions, I'm just looking for if there is the Oracle . No. Okay, now let's create partition new primary 1, accepting the default, and we're gonna use T to change the type, or no, not yet. Okay, AD3 as a Linux partition, right, and then print. Okay, once after we complete the fdisk process, we have sdb1 as a Linux partition. Okay, as we have this as a Linux partition, let's execute the command which allow us to put the label on that specific partition. Okay, let's see if this will work for us. Okay, the formatting journal will take a couple minutes for the partition. That we have to be patient. Now let's do the F disk. Okay, we still have our SDB1 with 83 as Linux. And now we can't mount this partition under our folders. Okay, we want to creating the folder /data, and we're going to mount this partition under the data file system. Okay, and now we see we have a new folder, data, with 50 gigs, 5% usage. Okay, let's go to the data folder and touch app1.txt file. Okay, we see that we have a file app1.txt. Now we're going to the second server. The second server don't have data folder, but let's create data folder. And also let's map our volume. Okay, here it's not found. Now let's executing this same. Okay, we have a F disk. We have this partition already here, SDB1, but the second server don't know our label because the label was created only on server 1. But let's executing also that label creation on server 2. Okay, I just go to F disk and exit from F disk, and now this command is working. Okay, the volume is used in the cluster. It is used because it's used here in 1. Let's see if we can use the mount. Sorry, this is wrong command. Okay. Okay, this time the process recognized vol data and it mounted. And we have an app1 file. Here we're gonna create app2 file. We have app2, and when we see this on server app1, we have app2. Now, why we had the challenge? I think this is related to refresh, and this which I did going to F disk and trying to MKFS one more time, it just refresh. maybe we should just restart the process on the second server to refresh the data set. That this we can exercise and see. But like you see, the primary objective of this exercise to creating the shared drive is achieved. We have now the shared drive where the servers are having the same data set. But now let's use this data folder and we will move our web files to this folder and see our application. If when we put the load balancer IP address in browser, we should get data right now from this shared drive. Okay, where is our file system? Okay, share nginx HTML. Okay, that here I'm going to creating nginx folder and I'm gonna create an HTML file, HTML folder. Okay, and now let's copy user share nginx HTML to here. Okay, now I copied the nginx files from the shared drive to from nginx location, nginx HTML, which is the default location, to the shared drive. And to see this, okay, here we have the app2. I'm going to remove this and I'm gonna put here data shared. Okay, now when we're going to the load balancer IP, let's see what is our load balancer IP. As you remember, like yesterday, we have a app1 and we're gonna refresh. We have app2. Okay, that now those files are on each server. But right now we're not using the shared drive, we're using each server files. Now on server app2, I'm gonna link that location to this location. Okay, this is data. Just making the note. Now, nginx configuration, I'm gonna change the root. Okay, this directive, root directive, is telling the server where are the files where they're supposed to serve when somebody is asking for. Okay, I'm changing this to data nginx HTML and service nginx restart. Now, what is right now our expectation? Right now, our expectation is that when that request coming to app 1, it will display app 1. When gonna call to app 2, it will display data share. Welcome. Because now this app 2 is using the shared data storage to provide the file system. And let's refresh. And we have data share. Now we're gonna refresh again. And we have app 1. And like you see, the load balancer is changing the server, and server is using those respective files. Okay. Now, app 1 server. Let's change the location in app 1 server. This way, every time when we refresh the request, we always will receive the same response. Command.line. Service nginx. Okay, that now the expectation is every time we refresh this page, we always will see the data share, because now both servers are using the same data set. Okay, and exactly how it's expected. Like you see, this does not change. We don't know which server we are reaching. The user who requests the page receive that page. He don't care if he get this from app 1 or app 2. He receive the page which he's asking for. Now, in the logs folder, we can see that when we access the server where this request is coming from. Right now you can see the request from load balancer. It is getting the 200, that the load balancer keeps both servers up and running. Okay. Now when I refresh this page, see, we get actually request to both servers. Now, maybe that page is triggering some 2 requests, and now some requests come here, some requests come here. Okay, now the request came only here. Let's refresh again. And now, okay, it's doing 2 requests, because now one request is favicon icon, and then the second request is the complete page. That in run one request, there is not just one response or one request. How we can see this? The user is requesting the web page, but in Webmaster Tools, you actually can see how many requests that request generates, and it's going to the server. Okay. Now, what will happen if we will shut down one of the servers? Let's go to our load balancer. We are load balancer 1. The backend servers. backend set, sorry. Backend set, and we're looking for our application. Okay, in load balancer config, we see both servers are healthy. Now, app 1, I'm going to stop nginx. And as I'm stopping nginx, now let's request the page. We have success, we have success, we have success, again success. Okay, we're getting the 304 502 status, but the page is still displayed. We're not getting any failure from the page. We get the page load, right? And you see in the log, all the logs is going here to app 2, because of course app 1 is shut down. But this that I shut down one server does not affect the application availability. Application is still available, application is active, application is available to users. Okay, now if I'm gonna shut down the app 2, then the system will be not available. Let's stop app 2. Okay, now I stop both servers. Now I'm getting 502 bad gateway. Why there is 502? Because now load balancer have the failure and is not able to get the response from either one backend server. And like you see here in the load balancer check, we already have app 1 in the critical state, app 2 is still okay because was good. Now when the next health check will go, it will validate that we have a failure. Now, the health check is the 15-second, 3 times retry that I think it's gonna take like 45 seconds to really bring this server as a failed server. Okay, we have a status 2 that right now both servers are failing. And yes, we have a failure. Now, let's start. Okay, perfect. We have both servers right now are marked as a failed servers. Now let's start the service on one of the server. We type the logs and let's see when we will have the success connection. Okay, we see we're getting the log connections from the load balancer, but the website is still not available yet. Okay, I'm just keep refreshing. You're hearing me clicking. Okay, now we get the request. And as we see here from the log, from the first successful response 3237 till 3216, that we have approximately 30 seconds delay from the first successful response from from the server to load balancer till the website is available for people. Okay, but still we just bring up one single server. Now, and let's see our load balancer. Okay, in load balancer here, backend are still showing 2 failures that reporting to the console. It's a little bit delayed, and now finally it shows the server 2. Okay, fantastic. Now let's start the server 1. Okay, we start the server 1, and when we're gonna tell, let's see when finally, okay, we finally get the connection from the application from load balancer. You see there is the one entry in tab window. We have additional entry that load balancer is coming in and checking the health check. Is not sending yet the traffic to the second server, but already know that the second server is good. Okay, and finally we're getting the response and traffic to both servers. Okay, that let's see, we have a 40 and 3516. That's again approximately 35 seconds, 40 seconds later after our initial request, success request from load balancer to the server, till the load balancer allow the traffic passing through and start sending the traffic to those servers. Okay, we're completing this exercise. That with this exercise, what we did, we had 2 servers. Both servers had local file system. That means if you have to change the file, you have to change file here and here. Now we're creating the common file system and assign this file system connect to server app 2 and app 1. Once we're connecting this, we creating the Oracle Cloud file system, we're creating the cluster, and now we see that each file, when we change the file is the common file. So far we used the default nginx file system. Now let's creating our test page and exercise with our test page. Data. Okay, I'm just making the sample. Now, my test page is owned by the root user. All the file system is owned by the root user. That now nginx is running as nginx user. That nginx can read this file system but cannot modify this file system. And if your application has to modify the file system, application has to be running as user who own those files. Okay, and of course not preferable to run this as root. You should have the application running under specific user. Okay, now let's test HTML. Let's connect to our page. We have a test page. Okay, and now what happened? Right now I just go to server app 1. In server app 1 I creating the file test HTML, and test HTML is available right now for both servers. I do not have to go to each server and update this file on both servers. I'm just doing this on one server. And because that file on share file system, that test file is available on both. And like you see, the requests are coming to both. Let's minus log nginx. Okay, you see the logs, and we'll see the request coming to both servers, server 1 and server 2, and both servers have the same data file, and both servers can share that file. That I can shut down either one server, I can perform maintenance on that server, update, restart, some test which I have to do on that server, take that server out of the production array which supporting the production data, and your production data is still working, your application is still up and running, and whatever we have to do on the maintenance side does not affect your production side. This is why you need the high availability to ensure that anything what you have to do does not affect your application, and users who are coming to your application will still see the success response and it will still see the successful application. All right. Okay. This we complete our that section. We completed this section where we add the shared drive. Now we connect to two servers. We connect the shared drive. We move the files for nginx web server from the share folder on each server to shared drive data folder, and we see that servers are sending the data from that share location. We add the new page. We can do the changes only from one server. The files are available on both servers immediately. And we exercise shutting down one of the server, create the problem, create the error state where load balancer don't see the connection to your backend server. Okay, and now as we're watching the log file, you see some requests already coming in to your server, which is looks like there is some kind of hacking exercises here, because it's going to the different servers, different requests, and somebody is trying right now access that server through hacking and testing your server. Thank you for being here with me on that session. See you in the next section.